the cylinder is going to cycle for his life.
So I think that's a considerable advantage. But I think it must be hard to manufacture or to make these aluminum shapes and all these composites. Can you say how you do that?
Yeah, so it's a different process than having made a liner out of a tube. So by forging the tube, we are getting different. We get very large diameters, which is our focus. To get diameters over the dimension that you normally buy in extruded pipes. Therefore, we start with the forging, as you can see on the left slide. The forging is more like a dish, and then we start spin forming after that, and flow forming made out of tube of aluminum stock of 6061. So we start with a 61 tube. 61 billet and go into the tube shape at the end. There, the next pass is then closing the tube at the ends. Afterward, they are heat treated to T6 conditions, and the machining at the ends that you can see here, the machine on the outside is to mount the mounting blocks for the cylinders. So that's an outside machining, and the inside machining is to mount the valves.
So that is a neck mount you have there. So
this is the neck mount. There is also in some applications strut mounts. The neck mount is a very clean mounting. It is easy to inspect. It's also not touching the carbon fiber, which is a significant benefit versus the strut mounting.
Okay, understood.
Further on, we go to wrap the cylinder. So we do carbon fiber wrapping with, we use a wet process. There's wet and dry. The dry process is with pre-pack fiber. We use the wet process, which is probably the one most used in the market. And then we do the testing at the end. Every cylinder before it leaves the factory is tested 100%. Which is the out-of-attache and the hydro testing.
Okay.
The out-of-attache testing lays the aluminum into the carbon fiber. The carbon fiber has a very low elongation. It's about 2 to 3%. When the aluminum has elongation, the 6061 between 12 and up to 16-18% in different cases. So therefore, the aluminum is stretched into the carbon fiber under high pressure. And then the hydro test brings it back to the original form. And there, the liner will cycle between those two areas for his cycle life of 15 years in case of the hydrogen cylinders for high pressure.
Sorry, I need to ask, can you say that again? So the tank is actually expanded, and the fiber brings it back into shape, or did I get this wrong?
So yeah, the tank, the liner is expanded into the wall of the carbon fiber.
The liner inside.
Carbon fiber has a very low elongation, but the liner let it expand itself into the wall, and from there. Doing afterwards the hydro test, which is at lower pressure, between those two areas, the cylinder is going to cycle for his life.
Okay, understood. Okay.
Doing filling and unfilling or the defilling.
Okay, and when you wrap that around the tank, just out of estimate, how long is the liner that you put? Like, is this? You know, like I always imagine that there's supposed to be endless, let me say, miles of tape that goes around there.
Yeah, so it pretty much depends on the pressure. More pressure, more carbon fiber binding.
Yeah.
The aluminum or the liner is pretty much only a container for the gas. What gives us the integrity of the cylinder itself is the carbon fiber.
Okay.
So the higher the pressure, the more fiber we get on those tanks, And you can see in this one here,
Yeah.
the carbon fiber thickness is much more than the aluminum thickness on the wall.
Yes.
So the pressure is really depending how much fiber we have to wind on. How long does it take? Yeah, it depends on the equipment. There is very sophisticated equipment that has a better output, a higher rate. I would say for a cylinder, it depends on the size also. On average, it's about an hour. There's multiple spindle machines available that can do more than one tank at the same time. So it depends on the equipment.
Wow. Okay, but I mean, an hour is, I think, is pretty good for such a big tank, considering the diameters you do.